These are the topics we looked at. Inheritance in Java is done between the parent-child classes with the help of the word extends. Overloading allows you to create more than one methods with the same name but difference in parameters. Overriding allows you to create the same method in the child as the one in the parent. So child inherited the method from the parent, but decided to create its own version of the method. We can also create more than one children of the class, but we cannot have more than one parent. That's why we use interfaces to allow for multiple inheritance. Abstract classes are incomplete classes. So the classes that we have done before abstract classes are called concrete classes, means complete classes. Abstract classes are incomplete, so the child has to complete them. Dynamic polymorphism and interface. That's what we will be looking at today. And overloading and overriding are basically polymorphism. And polymorphism means more than one implementations of the same idea. So the same method name, but difference in parameters, or the parent-child having different implementation of the same method. These are all polymorphic behaviors. And public allows free access, private allows a block, which is called an encapsulation. You're hiding the underlying details. And protected is only something that is only shared between parent-child. And also we learned that whatever is in the parent can be seen by the child, can also be seen by the grandchild, and it just goes all the way down like that. Okay? So, any questions before we start with our first example? So to start, we will start with our very first class, which I want to call my first class robot, robot.java. No main, robot, I'll create a very simple class here. So robot.java will have one method called move. System.out.println, robot is moving. So we decided to keep the example short just so that we can cover more concepts. So in this class, we do not have any properties. We do not have any getters, setters, nothing. It's just one concept I want to go over, which we learned last time, which is about having multiple children. So that's why I'm not going in too much detail. Okay, so we'll start with our next class, which will be called wheeled robot, wheeled robot.java. So public class wheeled robot extends robot. Okay, so we will create a method here called calibrate wheels, and a very simple method which will simply display an output saying that calibrating wheels. Okay, so calibrating wheels would be the only method that will be in this class. For now, we are, again, keeping things simple just so that we can revise the concept of having multiple children. And then we will learn about overriding in the same example. For now, we are just keeping it without overriding. Okay, so we will now create our third class called flying robot. Flying robot.java. Flying robot will also be the child of robot. So this is to show you that you can have multiple children of the same class, and this one will have a little different method called adjust altitude. So system.out.println adjusting altitude. So we have two children classes to the robot. One is called a wheeled robot, which has its method called calibrate wheels, and the flying robot, which has a method called adjust altitude. So we have one class called robot with only one method, move. We have a child class called wheeled robot with only one method called calibrate wheels. And then we have a flying robot, which is also a child of robot with one method called adjust altitude. So right now, 2 children, 1 parent. So now let's create a testing class here. So for now, we will have our demo.java. So public class demo. And in this class, I will create a child of robot. I'll create a child of wheeled robot. And I'll create a child of flying robot. So I have one instance of parent type, and I have 2 instances of children type. Children instances can call their local method as well as the method in the parent. Parent instance can only call the local method. So for robot, the only method the robot can call is move. But for wheeled robot, it can call move as well as it can call its local method, which is calibrate wheels. And for flying robot, it can call move as well as it can call its local method, which is adjust altitude. So this basically shows you that the parent can only access the local method and the children can access the method in their respective class and also can access the methods in the parent. But siblings cannot see each other, so the wheeled robot object cannot call adjust altitude. And the flying robot cannot call calibrate wheels. So if I run this example right now, you can see that robot is moving the very first output that comes from line number 7. Then the second and the third output, they're coming from lines 9 and 10 from wheeled robot. And the last 2 lines of output are coming from the flying robot. So each of the objects can call move, but only the wheeled robot and flying robot can call one additional methods, which are local to their own classes. Okay. Next, we will incorporate overriding. As I told you before, that overriding is when you have the same method in the child as you already have in the parent. Right now, the method move is being used by each of the child, same one that is in the parent. But if each of the child decides to write its own version of the move method, that will be considered overriding. So we would now like to override a method move, which would now be very specific to the wheeled robot. So now when I say wheeled robot is rolling on wheels, so now if I call the move method on a wheeled robot object, it will not call the move in the parent. It will now call this one. Go ahead and test this. After you write lines 3 through 5 in the wheeled robot, go back to demo and run the demo again. And this time, you will see for R1, the robot is moving, but for the wheeled robot object, which is WR, you will not see robot is moving anymore. You will rather see wheeled robot is rolling on wheels. because now it is using the overridden local copy of the method. So now let's go to demo and let's run demo. And you will see in demo that the wheeled robot will call its local move method, which is wheeled robot is rolling on wheels. Okay? So wheeled robot is rolling on wheels. That is coming from the local version of wheeled robot. So robot is the parent, has a version of move, which is robot is moving. Wheeled robot decided to override that. So that's why it now says wheeled robot is rolling on wheels. But flying robot did not override the parent's method. That's why the flying robot object still says robot is moving. So any child that override, only its objects will reflect that. Any child that decides not to override, then it will take the parent's version. Okay. Now let's go to flying robot and also override at override public void move system.out.println. Flying robot is flying through the air. So we are now writing a move version for flying robot. After this change, go ahead and run demo again. And this time your second last output, which says robot is moving, adjusting altitude, that robot is moving will now change to flying robot is flying through the air. So let me run the demo. Flying robot is now calling its local version. So all of these classes we have created are called concrete classes because all of them are complete. When class is complete, you can instantiate an object. When the class is not complete, what is it called? Abstract. Abstract classes cannot instantiate an object. And abstract classes must have at least one abstract method. So let's go back to robot.java and let's create and make it an abstract class. So public abstract class robot. So we would have to make this public abstract void move. And abstract methods don't have bodies. So we will replace the body with a semicolon. Abstract methods are incomplete. And abstract methods must be in an abstract class. And an abstract class can have, this was one of the quiz questions last, like on Thursday, then an abstract class can have abstract as well as non-abstract methods. So all methods do not have to be abstract. What does an abstract method tells children? That all children must write the body of the abstract method. In our case, we have already done that. Each of the children of robot, which is wheeled robot, has a local version of move, and so does a flying robot. If I take out lines 2 through 5 from flying robot, it will give you an error. So a child of an abstract class must write the body of an abstract method. So this is a way for you to force a child class to write an implementation. What is the other advantage of writing an abstract class? We do not want anybody to be able to create an object of abstract type or parent type because it's so generalized. So to stop them from having to create objects of most generalized type, we want to create the generalized type abstract. For example, if you have an organization with full-time and part-time employees, they both are employees, so both classes are children of an employee class. You do not want anybody to be able to create an object of employee type directly. Demo right now needs to be fixed. Why? Because demo is instantiating an instance of robot, which is not allowed. You can't do that anymore. because robot is an abstract class. So now after you comment out line number 3 and line number 7, because robot can neither instantiate nor call, but it can be used by the children. So now go ahead and run it. And now you should be able to see the output. Okay, now we will get to our next concept, which is dynamic polymorphism. A dynamic polymorphism means an object is able to change its point of reference on the fly. Okay, so what is dynamic polymorphism? Dynamic polymorphism is object can change its point of reference dynamically. So it is not locked in a point of reference. So for example, an object of robot type can point to wheeled robot at one point in time, and then later on in the code, it can point to flying robot. It can just change itself like that on the fly. So that's what we'll be looking at next. How can be done? Okay, how it can be done. So we have robot. Let me make some changes here to this code. So let me, for now, delete the flying robot and all of the lines that I do not need. So I'll just delete all of these lines for now. This is what's left over from the code. So I will create an object of robot type called WR. But since robot is abstract, it cannot have an object of its own. It can't even have a constructor. So it is calling the constructor of a child. So right now, robot object is behaving like a wheeled robot. That's its behavior right now. So robot object is behaving like a wheeled robot at this point. So it can call move, but the problem is it cannot call calibrate wheels. We'll fix that problem in just a minute. Let me run it to show you what the error will be on the screen. It will give you an error saying robot object cannot find symbol means it cannot find calibrate wheels because robot class doesn't have calibrate wheels, but it is perfectly fine calling move. So let me comment out line 8 and run it again. You will see an output. So this dynamic point of reference is showing you that the robot object, which is a parent type object, can change its point of reference to a child type, which is wheeled robot, and call a move method. And notice it is calling the local move. Now I can use the same object R1. I do not have to restate robot R1 equals to because R1 already exists on line number 5. I can say R1 equals to, and now the same R1 will stop being a wheeled robot, but right now what happens is the robot object is behaving like a flying robot. So it can dynamically change its point of reference. So now when I say R1.move, it will call the move method in the flying robot. See, the first output wheeled robot is rolling on wheels. That comes from line 7. Same object R1, when calls move on line 11, it is now displaying flying robot is flying through the air. So same object change its point of reference from one child to another, and this is called dynamic polymorphism. This dynamic polymorphism can also be applied if I want to maintain both point of references at a time. I could actually create an array of dynamic objects and dynamically assign different children to different objects. I could actually do that. In fact, I will do that in this example. I will create robot as an array, and then I'll give first element to wheeled robot and a second element to flying robot. So robot R equals to new robot size 2. R0 is wheeled robot, and R1 is flying robot. Same output. It's just like now I'm maintaining both objects in memory at a time. So on line number 5, I requested the computer that I need 2 instances of robot type. And since it's an array, the first instance is 0, the second instance is 1. I'm making the first instance R0 point at wheeled robot, and I'm making the second instance, which is R1, point at the flying robot. So I'm maintaining both references in memory. Now, let me delete line 7 and also delete line number 9. Because if I have an array, I'm better off running a for loop where I can just take one object at a time from the array and simply use that object to call move. Just like that. So first time it will grab from R0 an object into an object, and then we'll call move on R0, and R0 is wheeled robot, so it will call the version of move from the wheeled robot. And in the next iteration, since R1 is a flying robot, dynamically object will now become flying robot and will now call the move in the flying robot. So this is also, you can see some dynamic polymorphism here, because object is constantly changing its point of reference in each run. A very important question still stays on the table, and that is this. Okay, common methods are being called without a problem. No big deal, right? How about, how will I call the uncommon methods, right? That is the biggest challenge, to be able to call the uncommon methods. That's what we will be incorporating in this loop next. But I want to make sure everybody gets to see the output this far. And this is where I want to incorporate how we can call the uncommon methods in dynamic polymorphism. So how about we put a curly brace at the beginning of the loop and put a closing curly brace at the end of the loop. Just add this for now. And we will be learning something that we have not yet learned, which is using a special keyword called instance of. Instance of is a keyword that tells you the class name of the object. So you can literally ask Java, the object that I'm currently reading, what is its original type? So objects is sometimes behaving like wheeled and sometimes behaving like flying robot. So I can ask Java, what is the original object right now? So if it is wheeled object, then I want to call the method calibrate wheels. If it's a flying one, then I would want to call the adjust altitude. So I need an if condition here. If object is currently behaving like wheeled robot, then do this logic. If object is behaving like flying robot, then do this logic. I still need to write that logic that I want to do. So I just have written a couple of if conditions here. then object dot deliberate wheels. I'm not done yet, by the way, just so that you know. Object dot adjust altitude. This will still give you an error. We have to make one more fix. So if I run it like this, it will give me an error. So I need one more fix. But did everybody understand line 14 and line 17, what it is doing?
Yeah.
So all it's doing is currently checking to see what is the true nature of object. Now, object is still representing robot. So what I need to do is, on the fly, before I make a call, I have to do what we call a forced data type conversion. Does anybody remember what is the terminology for that? Forced data type conversion. What is the Java terminology for that?
Casting.
What type of casting?
Explicit casting.
Explicit casting, right? So I would have to explicitly cast object to wield a robot, and I have to explicitly cast object to flying robot before I can call the respective methods. Got it, Sadik?
Yeah, I got it.
Okay. Okay. Alina, Hamza, and Abdurrahim, all good?
Yeah.
Yes.
Yeah.
Okay. Now let's move on to our next concept, which is about interfaces. Interfaces are typically used, as I told you, because we do not have multiple inheritance. Interfaces allow you to create a class through which you can force certain behaviors across the board, like to multiple classes. So if you want to have a set of behaviors that you cannot force through a parent, rather you are working with 5 different classes and they have different parents, but you want that particular behavior in all 5 of them who do not have a common parent, you can force that through a common interface. So interface is not really a class. Interface is like an abstract class where you cannot have a non-abstract method. All methods have to be abstract in an interface. So let's say if I create an interface called communicable.java. And this will be created as an interface called communicable. And this interface will have only one method, let's say it's called transmit. And as I said, all methods by default are abstract in an interface. You do not even have to write the word abstract because it is understood that the method will be abstract. So we will create a class called Bluetooth module.java. So public class Bluetooth module implements. So we don't use the word extends. We use the word implements for interfaces. Implements communicable. Now let's say if I have public static void main. And I decide to create an object of Bluetooth module type. Do you think this will work? Okay. So what do you think? This will be an error?
No, it should work.
Should work? Okay. It didn't work. Why it didn't work? Remember, Communicable has one method. Transmit, is it complete or incomplete?
We didn't make it abstract, so is that why?
Automatically, all methods in interface are abstract. That's why you don't write abstract. They are incomplete. So since the class Bluetooth module, which is implementing communicable, did not write the body of the method transmit, that's why it's giving you an error that you have an abstract method, but you never coded it. That's why if you look at the error message, it reads Bluetooth module is not abstract and does not override the abstract method. So you have to code the abstract method. So public void transmit string data, and then this is where you can have a system.out.println sending via Bluetooth and whatever data you are sending. Now, when you run this code, it will not give you any problems. Means it will not give you any error. It will not have any output either. It will not give you any errors because you have successfully overwritten the abstract method. Okay, it gives you no output. If you want to have an output, then go ahead and call transmit and literally pass some data such as so now it will transmit that particular data item to the Bluetooth module transmit, which will then display the output that's sending via Bluetooth. A bit is sitting here. So that will be the output. So let me run it again. There you go. So sending via Bluetooth, and this is the output. This is the data that I send to the transmit, which then displays the data next to sending via Bluetooth. So interfaces are automatically implementing nothing but abstract methods. So you have to code the body. Okay? Got it?
Yeah, I got it.
Next, I want to do a more concrete example where I want to incorporate all of these concepts in one example. So the same example will have abstract parent, will have a child, will have an interface, and all of them will be then controlled via demo, which will be the running playground for the entire infrastructure. Okay? So our first one in this whole process, we will call it drive train. Drive train. Oops. Drive train dot Java. This will be my abstract class, public abstract class drive train. And how about we also use protected? Protected means it is only shared between parent and child. Public drive train. Public drive train What do you think I did here? What do you call this, what I just did here? The two versions of constructors. What is this called? Having more than one constructors.
Is that the overloaded constructor?
It's overloaded constructors. Awesome. And in this case, we always can make a this call from one constructor to another, right? We want to have a public void method called diagnostics. And diagnostics will display drivetrain with so and so number of motors. So it simply displays that how many motors I have in my drivetrain. That's what the diagnostics does. So since my class is abstract, I need to have an abstract method. So public abstract void move. Move is my abstract method. So a child of drivetrain will have to write the body of the move method. And let's say I want my move method to take a parameter of string type called direction. The next one, which will serve as my interface. So let me create an interface called motor controller.java. So public interface called motor controller. Okay, so public interface call motor controller. So motor controller will have a public void. Set speed is one method, and remember, all the methods in an interface are by default abstract. So anybody who implements the interface must write the body of these methods. So we have two methods in the interface called set speed and stop. So remember our drivetrain class, it has one property called motors. It has two constructors, and their job is to set the number of motors to the value for the motors. And then it has diagnostics, which is to display how many motors are there, and an abstract method move that a child must implement. And then we have a motor controller interface with two abstract methods, one to set the speed and other to stop the motor or stop the motor. Let me know when you guys are done coding motor controller.java.
Yeah, I'm done coding.
A question for all of you. If I create a class which becomes a child of drivetrain and also implements motor controller, how many methods that class would have to code or must code?
Could you please repeat your question?
If I create a class that becomes a child of drivetrain and also implements motor controller, how many methods will that class must code? How many methods that class must code? Otherwise, it will be an error.
At least two, right?
3. Why 3? Because remember, drivetrain also has an abstract method move. So it must code move, it must code set speed, and it must code stop. Everybody follow that?
Yes.
Okay, because all the abstract methods must be coded. Okay, now let's get to the child. The child will be called tankDrive.java, tank drive. So public class tankDrive extends drivetrain, implements motor controller. So as you can see in this example, we have a class which is a child of drivetrain, and it also implements motor controller. Okay. Private double speed, public tank drive, number of motors, super motors. Now, as I told you that there are 3 methods that you must override. So how about I write at override 3 times? I have 3 methods to override. Okay. So public void move. Who created move? Is it motor controller or drivetrain? Who has move?
Drivetrain.
Drivetrain. Okay. So I will be writing system.out.println tank drive moving. This is the direction of my tank drive at speed. And this is the speed at which my tank drive is moving. My next override is coming from motor controller, which is set speed and stop. So public void set speed this dot speed equals to speed and system dot out dot println speed set to this value. Oh, somebody else said, okay. So when you are coming to stop, you're setting the speed to 0, and the output will be tank drive stop. So these are my overridden methods. So I have a method which tells me in what direction I'm moving and at what speed. And I have a method which allows me to set the speed of the motor. of the drive, sorry, a drive, and also set displays at what speed the drive is. And then we have a method called stop, which set the speed back to 0 and then notifies that the drive has stopped. So we will now get to our next Java, which will be our demo2.java. This is where we will use all these classes, so public class demo. So let me create an object of tank drive, and I will set a parameter. So remember, tank drive constructor needs the number of motors. So I'm passing how many motors I have. Okay. So this basically is telling my tank drive how many motors I have by simply passing a parameter. So our tank drive, we have 4. Okay. Now I am running diagnostics on my tank drive. Oh, demo 2, my bad. Demo 2, not demo. So it will basically give an output when I call diagnostics. Diagnostics simply tells me, where's here? From the parent, that how many motors are running. So when I say tr.diagnostics, it calls the method in the parent class. So it is calling the diagnostics method in the drivetrain class. Okay. Now if I use the TD to maybe, let's say, call set the speed. Okay, let me call TD dot set speed to a speed like this, and now it will tell me that the speed is set at so and so. Oh, TR, sorry, not TD, TR. So it tells me that I have 4 motors, and this is so this time it calls the method in the local class, or I should more specifically say it calls the overridden method from the local class, because set speed is actually coming from where? From motor controller, the interface. That's what we overrode here, and that's the one that is calling. Then I can say, okay, I want my tank drive to now make a move forward. So now it calls the overridden method in the local class again. But this overridden method is actually coming from the parent. Is it coming from the parent? Yeah, it's coming from the parent, drivetrain. Remember, we have an abstract move. That's the one we are calling. Let's run it. So the first line, which is line 4, will display an output, which is 4 motors. The second line will say the speed is currently set at 0.7. And then when I say move forward, it will then tell me that tank drive is moving forward at speed 0.7. So when you are actually coding this for yours, what will you do? Instead of displaying an output, you will actually call the mechanism which will make the robot go forward. Okay? Whenever you call the move. Similarly, you may have another version of move for reverse or sideways.
You need different move versions.
You can, that's one way, or you can have one move version, and based on the parameter you're passing, you can have an if condition. That if the parameter is forward, move forward. If parameter is backwards, move reverse. like that, you can have an if-else structure.
Okay.
Okay. Similarly, let me change the speed. Now, let's say I'm reducing the speed by this amount. So now my train starts running at a slower speed. Okay. And then I will bring it to halt.
GD or TR?
Oh, sorry, TR, you're right. Thank you. TR. Everybody got it? Another full example with multiple classes. So I want to start out with a class called armbase.java. So public class armbase, or let me rather do public abstract class armbase. With a couple of properties. One is a protected string name and another one is protected int max length. So public armbase this is my constructor. So arm is operational at so-and-so max length in, let's say, centimeters. I believe you guys work in inches, right? Yeah, okay. Whatever is the unit. Okay. Now let's create our interface called controllable. So public interface called controllable. It will have two abstract methods called activate and deactivate. Let's go to our next class, which will be hydraulic arm.java. So public class hydraulic arm extends arm base, implements controllable. So how many methods will hydraulic arm must code that are abstract? How many methods should hydraulic arm code that are abstract?
4.
4. How many are There's only one abstract method that's coming from parent ARM base, which is extend, and there are two coming from controllable, so it's total
Oh,
three.
okay.
Okay.
I
Anyway,
thought we were also doing status.
status is not abstract; it's already coded. So, okay. So for now, we will say public hydraulic arm will get two parameters. One will be the name, and other one will be the max length. And what it will do with them, if you remember ARM base, it needs two parameters, name and max length. So it will simply make a call to the parent and will pass both of those parameters over to the parent. And let's say the current length is currently set at 0 for now. I will have three sets of override, one for each one of the methods I'm overriding. One method I need to override is extend, which comes directly from the parent. Extend. So current length is set to be same as max length. I'll give everybody a minute or so to catch up this far. Then I have a question to ask. Very small majority of the week. Almost every day we have this kind of weather this next 5 days. Okay, here is the time for my question. Current length is declared on line number 2, so I can access it. Where's max length? Where's the max length declared? Don't say it is coming from line 4, because that max length is local parameter to hydraulic arm, and it will not exist past line 7. So where is this max length coming from? I'm not passing any parameters also. I don't have a property called max length. So where exactly is this max length coming from?
ARM base?
Very good. In the ARM-based class, we declared a protected property, and protected property is shared between parent and child can use a protected property as if it owns it. Okay, so that's where it's coming from. Good job. System.out.println name so-and-so name arm fully extended to current length
Is there any other alarm going on? Something happening in the kitchen?
No. Put it down.
फायर अलार्म है ये
नहीं, it's a smoke alarm.
तो स्मोक कहाँ है किचन में कुछ है
Smoke alarm.
outside.
Okay, everybody got it this far? So, public void activate so and so arm hydraulic system activated. So the activate method will simply display that so and so arm hydraulic system activated. And very similarly, the deactivate will say the following arm was deactivated. Yeah, in the basement. Yeah. We're not done yet, but I just want everybody to catch up this far before we add more code. So far we have a constructor and we have 3 overloaded methods. That's all we have this far. Okay, so currently we have one version of extend, which when called, it will extend the arm to the maximum length. We want to have another version of extend, which would let me set it to a length, not maximum. So that's why we will have an overloaded extend method here. Overloaded extend method. So public class extend, or public void extend, not class, public void extend integer length. As long as length is less than or equals to max length, we can just simply set the current length to the length. As long as it has not yet reached the maximum length, we will display the output that so-and-so arm has extended to so-and-so length in centimeters. So as long as the length has not reached the maximum arm length of the hydraulic arm, then the current length will be equals to that length, and we will notify the user that so-and-so arm has extended to so-and-so length. If the length is greater than or equals to max length, then we will notify the user cannot extend beyond max length. So that will stop any extension. So if you try to go more than the max allowed, So, for example, based on the specifications that you get from FRC, if they say this is the max that you can go, then this is how you can control that. You will only let the arm go only as far as it's allowed. If somebody pushes in a value more, it just simply doesn't do anything. So either I can extend directly to max, which is extend, or I can extend to a certain length as long as I don't exceed max. And there's only one last thing left to be done after everybody's done coding extend, is to code the demo where we will test this class. So let me know when everybody is done coding this far. So I'm recording the class. So tomorrow sometimes I will release the recording to the Google Classroom. And that way you guys can watch it again. And also for those people who are not here today, because today is our last class, you can notify Safa and Mustafa to go and watch the class. Because I believe more topics we are covering, we are getting closer to the way you will code or the code is already done for you. So these are important steps to go over and learn. So is anybody still coding?
Yeah, I have like 2 lines left.
Okay, that's fine. So then we can test the hydraulic arm to see with different method calls. So let's get to our last class here called demo3.java, public class demo3, and we have the main method here. So we will create an object of hydraulic arm, new hydraulic arm. And hydraulic arm constructor requires 2 parameters, right? Name and the max length. So let's say the name is claw arm and the max length is 100 centimeters. So I need to first of all check the status of my arm. So this is coming from arm base class. Then I want to activate my arm, which is actually coming from controllable because I overrode the controllable for this one. Then let me do arm.extend, which is also an overridden method from arm base. So let me write overridden. And this is from controllable, also overridden. Okay. Then once I extend the arm, now let me extend the arm to a lesser value than 100, because when I call extend, it just extends to the max length. Now I'm retracting my arm back to 60. So this is my overloaded method from hydraulic arm. And then let's say I want to extend more than maximum. What do you think will happen when I do this? It will display the message that cannot overloaded method to test else condition, where I'm trying to go more than the allowed length, which is 100. 100 is the allowed length, and I'm trying to go to 120. So that's when it is supposed to tell me you can't do that. So now I will deactivate Let's run this. Here you go. So first of all, my program says claw arm is operational. Max length is 100. This is happening from the status. Then I'm calling activate. So it says claw arm system is activated. Then I'm calling an extend. So it says is extend to 100 centimeter, which is a full length. Then I'm contracting it to 60. So it says, okay, now it is extended to 60 centimeter. Now I'm passing a value that is over 100. So it says, well, you cannot extend beyond max length. And then I'm calling deactivate. So it says, okay, the hydraulic arm is being deactivated. So I wrote system.out.println, but when you will implement this kind of a code on your robot arm, then you will call the WPI library methods, which will let you do the actions on the robot. So I'm just giving you the skeleton code. You can lay the nerves and the mass and the skin and the soul, right? You can have a working robot.
Oh, why did you write arm.extend so many times?
Okay, the first arm.extend is a call to the overridden extend, which will set the arm length to maximum. So it will just extend itself to 100 centimeter. Then my next call of extend is to call the overloaded version of extend, which takes a parameter, and I'm passing a value 60. Now, since 60 is less than 100, which is my max length, it will then say that the arm is now extended to 60 centimeters. That is my if condition. Now I'm testing my else condition by sending an arm length of 120. Now, hydraulic arm cannot go past 100 because 100 is the max length. So if I set it to 120, it will go to else and it'll say cannot extend beyond max length. So I'm basically testing both cases so that you can see it can only extend as far as the allowed length. And then I'm deactivating the arm. Okay, so that brings us to the end of our today's class and this course. There are still a few topics, such as exception handling, file handling. So we'll see, if possible, we may have a couple of Zoom-like classes in August. We'll see.